Hi, this is Talon Jane. This is FTT 111. We are working on the week 8 final project, also known as the Fastener slab. Today is January 13th, 2023. Enjoy the video. We'll get started with kind of going over the basic parts of this lab and what we're going to be doing. We're going to be drilling 3 holes into this aluminum block, equally spaced. We'll be measuring those using these calipers, digital calipers. This is a punch that's used for a spring-loaded punch that's used for setting the divots where you'll end up using the drill bit to go in the hole. Mine's a little bit modified, it's just a little sharper. I don't know that we're going to use this tool. This is a Scribe. It has a very sharp little pointed tip. It's meant specifically for getting really fine lines when working in metal. This is a tap handle. Basically, we'll use our tap, which is the tap will go inside of this handle, and this will be what we use for tapping the holes. We'll need safety goggles or safety glasses while we're drilling the holes. For marking, we'll be using blue Dykem. Dykem comes in both blue and red. It's a little difficult to find. You can get it if you live in a bigger city, you can get it at a machine shop. Otherwise, just order it off of Amazon. Like I said, it comes in blue and red. Doesn't really matter which one you use. We'll be using the blue Dykem today. You're gonna need a cutting oil. I have a few different kinds. This one, CRC cutting oil, is a little thinner, kind of like a WD-40 thinness. You can get this at Harbor Freight. You can get cutting oil like Tap Magic at a few other hardware stores. I have some Oatly dark thread cutting oil. This is a little thicker. You can kind of hear it's kind of a goopier thread cutting oil. We won't be using that one. We'll be using this one. Instead of the blue Dykem, if you don't have that, you can use a big Sharpie marker and just color the whole surface. The purpose of using this versus like a pen or a pencil or a marker is that you just get a lot finer line. These are a lot of the bits and tools and jobbers and screws and bits that we got from the SDI schoolhouse. We'll go through each one of these as we're going through it. Finally, we'll be using some gloves. This is mostly for the Dykem, just to keep us from getting blue Dykem everywhere. That's also why I'm using this here. Dykem stains really easily, so just be cognizant of that. We'll be using this little rotary tool to cut the fastener head off when we go to do that part of it. So it's got a little cutting bit on it. So with that, that's everything that we're going to be doing, and we'll begin the layout portion of this next. All right, so in order to get this properly laid out, we need to get an accurate measurement. With this caliper, it doesn't automatically zero, so what you need to do is set it all the way closed, hit the 0 button, and I prefer, when I'm doing a layout like this, to use millimeters instead of, say, inches or fractional inches, but we'll be using millimeters in this one. So just as easily you could flip this over to inches and do it just as easily there, but we're going to do it in millimeters. All right, so the first thing to do is get our width, which it looks like we're at 52.16. We'll just make sure that's consistent. Yeah. Yep, okay. So we will write down our width is 52.16. Our length around 102.80. Make sure that's about the same. 102.80. 102.80. Okay, so length is 102.80. All right, so in order to get this directly in the center here, we just need to divide 52.16 in half. We can do pretty easily on the calculator. So let's pull that up real quick. Alright, 52.16 divided by 2, 26.08, 26.08. And then in order to get the dead center the long ways, we'll take the 102.80 divided by 2, 51.4. Okay, so then what we'll be doing is we'll be setting this at the 26 point, let's see, so we'll go down here, 26.08. We're talking just very, very little bit right there, okay? We lock that in. Okay, so now this is locked in at 26.08, so it should be, if I make a mark right there and I go to the other side and pull this way and make the same mark, it should be on the same line, which it is. All right, same thing we'll do the other way. So now that we've figured out our measurements, just to get our center dot, we'll still have to get ones for the sides, but what will end up happening is you can do, so what we've done now is we found this dead center dot, okay? We still have to find these two dots right here, which we know that we know the distance from the sides that they're gonna be. We know this distance here because that's it right there, okay? What we don't know is the distance from here to this centerpiece. So we know that at 51.4 from the edge is where this one's gonna be. So if we divide this one in half, you know, divide that one by 2. Oops. So we can do 51.4 divided by 2. That'd be 25.7. So now this dot right here is 25.7 from this dot. It's 25.7 from this line, okay? Likewise, this one here is 25.7 from this line and 25.7 from this dot, okay? So, you know, you can measure from this edge, 25.7, measure from this edge, 25.7 to do it. If you just want to go from one edge, you can add 25.7 to the 51.4. So we can plus 51.4. So this, from this edge, this dot should be 77.1 away, and from this edge to this dot should be 77.1. So that could be just a way for us to double check our measurements once we get it. So now that we have this kind of layout guide, let's go ahead and apply the dicom. So I'm gonna go ahead and, oh, I already had that set. So I'm gonna go ahead and put some gloves on and we'll get started with this part. All right, so I warned you before, I'm gonna warn you again, this blue dicom stains really bad, okay? I don't know what was going on in the school's video of this. The brush the guy was using was so, I mean, it was just insane. I don't even know how to describe it. It was like, I'll put a picture of it, but it was just like all over the place while he was doing it. Now, I'm gonna go ahead and cover the entire surface because that's what the assignment said to do. However, if I was doing this myself, I would only cover the part that I absolutely needed to have the marks in. You're gonna end up having to uncover all of the parts that you use this, you know, like if you were doing this on a firearm receiver, you're gonna end up having to take all this dicom off afterwards. So, you know, I wouldn't necessarily recommend edge to edge and everything else because it's just not necessary. You really only need it in that middle part. All right, so this is completely dry now. When you touch it, it doesn't come off, which is what we're looking for. We'll go ahead and turn this back on. Even though it says 26.8, with the calipers that don't remember exactly where they're at no matter when, you always want to redo it. So I'm going to go ahead and unlock it. When I put it back to 0, it does show 0, but I'm going to go ahead and do there. We're going to go back to 26.8. All right, 26.8. Go ahead and lock this in. We don't need that on anymore, so this is locked solid. Now the 26.8 is the halfway. Again, to double check this, what you're going to do is you're going to come from one side, put just a little bit of line, then you're going to come from the other side and put that same line. And what should happen is you should have a single line right down the middle. That just verified that this is dead center. Now, when you're scribing using calipers or anything else to scribe whatever, your goal isn't to scratch the surface of the material that's on there. This is aluminum, it'll scratch really easy, okay? Your goal is to scratch away the dicum, the layout fluid. So all you're gonna do is very lightly, I'm gonna put it all up against this one edge, and I'm gonna drag this very lightly, and of course I bumped that. Right there. Okay, so I have my first line. Okay, now you see how super thin this line is. If I can even point out with this scribe. That's the whole point of using this method. Otherwise, you just grab a pencil and you grab a ruler and you put a line, but the, you know, that line thickness compared to the thickness of a pencil, even a mechanical pencil, is so much thinner. All right, the next thing we're going to do is we're gonna find that center point. So again, I'm gonna turn this on. It's nice as it still shows 26.8. Okay, so we didn't move it. We're going to zero it again. We're going to set it at 51.4. Okay, 51.4. Lock that in. Now again, I should be able to come from this side, put that little line right there, and do the same thing from this side, and that line should be in the same spot, which it is. So you see that little tiny line. Now another thing, in the video, they showed dragging it all the way across. We're only drilling 3 holes, and we're drilling those 3 holes on this line. There's no, it's not necessary to drag all the way across. You want to avoid scratching the base material as much as you can. I am already aware where that one needs to be. When I put this on here, I only need it to be that little tiny bit right there showing. So that's all we're gonna scratch, which is probably a little different than what the video had. So the next thing we're gonna do is unlock this again. We're going to go back down to 0. And we are going to find that 25.7. So let's do 25.7. Oops, bumped it. Honestly, if you're that close, it's probably fine, but just bumped it again, but at least it saved that time. Okay, 25.7. Okay, so now what that is that is the halfway point right here. Gives us that second line right there. And if we do this side, it'll give us that line. Now, like I said before, we verified our measurements all the way across the same way they do in the video. We verified that 77.1 should be from this line to here. So we can go ahead and turn this on, bump this up to, well, let's go ahead and 0 it just to be safe here. We'll go ahead and bump this up to 77.1. And now, just to check without scratching, I should be able to put this, look at that, perfect. So if I put that right on that edge, that line right there lines up, and if I do the same thing from this side, that line right there lines up. You see that? So now we have our 3 spots lined out, laid out. We're gonna go ahead, not gonna need this again. And what we're going to do is use this, which this is a spring-loaded punch. Mine is slightly sharper than when you buy it from the store. You can get these at Harbor Freight, Lowe's, Home Depot, wherever. What it is it's just a punch, looks like a nail or whatever, with a spring-loaded mechanism inside of here that basically, when you push down with some force, it will kind of resist to the last second, and then like a firing pin, it'll kind of push forward, and that push forward will put a dent. So now, this is probably one of the most important parts. If you want to get this perfect, which is why mine is a little sharper, you want to make sure we get it right dead center in that item, in that line, and that click. What that does is put just the smallest little dimple into our aluminum there. And we're gonna do that 2 more times here. And what we're gonna be doing now is begin the tooling process where we drill these holes. We're gonna start out with a center drill bit. What we're going to do is chuck up our center bit right here. So remember, this doesn't have to go all the way through the material. In fact, it just barely dimples into the material. So what did I do with the chuck? Oh, here it is. So we're going to tighten that up in there. Do a little spin just to make sure it's centered. Yep. Okay. Next, we'll be using the little vise to hold our piece in place. And because this is aluminum and we're treating it like it's a receiver, I don't have soft jaws on this one yet. I do plan on putting some soft jaws into it, but for right now, what I'm going to do is I'm just going to use one of these shop towels and kind of bury that piece down in there a little bit, and that should keep the sides from getting too marred up. I'm not worried about the drill catching the shop towel. It would rip it before anything, so because it's just paper towel. So next thing we're going to do is just make sure we're in approximately the right place. I'm going to raise this up a bit. Okay, I don't know, can you see? Turn it a little bit so you can. All right, and this drill press is nice because it's got a light on it, which makes it a little easier. So I'm just going to lower that down where I know it's got the right spot. Give ourselves a perfect spot for our drill bit to go into. And we're going to use our number 31 bit here. Now, I didn't state it before, but especially when you're drilling aluminum or drilling using any power tool, really, make sure you're wearing your safety glasses. There's a tap magic that's made for aluminum, and it works way better. But in the absence of being able to get the aluminum tap fluid, you need to have some kind of tap fluid. So I'm just going to spray a little bit here inside the hole. Okay. And some right here on that. Now that I can't see anything, let's go ahead and let that kind of fizzle down a little bit so I can see the hole. There we go. There we go. Now I can see the hole. So we want to make sure we're centered. And there you go. There's our 3 holes perfectly centered where they need to be. We're going to go ahead and head back down into the office and we'll tap these. So the only thing I did off camera was I took a little file and just kind of cleaned up the burrs off the back of this so that it would sit flat. All right, so this is the tap handle that the school sends you. I've used these a lot. They kind of have like 4 compression rings that kind of come down around. Not a huge fan. In a pinch, they'll work fine. I think you should go to Lowe's or Home Depot and purchase one of these. They just have a much more positive connection. They feel better in the hand, just a much better hand tap. So we're gonna go ahead and grab out our tap here. And you'll see the taps have a little square end to them. So it just makes more sense to use one like this. So what we'll do is just like that. Okay. Now, for drilling, this thread cutting oil was kind of weird, kind of foamed up or whatever. For tapping, it's a little less important. So I am going to go ahead and just kind of squirt a little bit of these into each one of these holes. And just use the excess here on this thing. Okay, stuff is wild. Okay, so when you're tapping, what you want to do is you want to screw in about 1 good revolution, then kind of break it off, then go in another good revolution, then break it off. Just about the time it starts to feel tight, you want to go backwards, and you'll feel the little chips inside kind of breaking off. Now, another thing is you want to keep this really level. A good way to do that is actually using your drill press or a mill to hold the top part of this. So it's like that. And then basically you're just working this centerpiece here. But for the purposes of this, we're just gonna eyeball it. We know the holes are 90 degrees, so this is a relatively small tap, so we shouldn't have any problems. So again, we're just gonna get it started. I wish I could have found that aluminum thread cutting oil, but that's what it is. So, okay, it's a little tight. We're gonna go back a little bit. These taps are really hard, but they're really brittle and they break really easy. There's 2 different kinds of taps. There's ones that are meant for going all the way through and they kind of have a point. The other kind of tap has a real flush fit bottom, and that's for doing holes that don't go all the way through. But those kind of taps, the chips come out, where this kind of tap, the chips go down. So when you're doing this, you want to make sure that you give room for those taps, those chips to come out. Go all the way through, and then we'll back it out. we have a good fit right there with that particular screw head. You see how it fits in there perfectly. All right, it's important with gunsmithing that you use the right screwdriver. That completes that part of it, of the drilling and tapping portion. For the first repair portion of this lab, they want us to repair a damaged screw head. Since I used the proper screwdriver to put it in place, it's not damaged, so we're gonna have to damage it. So I'm gonna use this little screwdriver. And what I'm going to do is, this is obviously not the right one. You can hear the slop. It's too small, it doesn't fit side to side. And what I'm going to do is kind of cam over the top. So what I'm going to do is, I'm going to chalk this up into the vise right here. I'm going to move the camera, and then we're going to fix it. First, I'm going to back it back out with the proper screwdriver. Okay, so we have the damaged screw. We're going to put it into the soft jaws of this vise. This vise has metal jaws, and then it has soft jaws and padded jaws. So for this, we'll be using the soft jaws. Tighten it down in there, not so much as to mess up those threads. I'll change the angle of that just a little bit for ease. Okay. Then I'm going to grab our pack of files here, and we're going to grab flat files. And what we're doing is, we still want very vertical walls on either side of the screw head that I damaged. And honestly, these files are a little thick for this task, but let's see if we can get in there. Alright, let's see if we can get the camera in here a little closer. Alright, I don't know if you can tell, but we removed all the burrs, but we also removed the finish. And that's kind of, when you're repairing a fastener like this, when you're repairing a little screw head, it's a back and forth process. So you know, do the inside, do the outside, do the inside, do the outside, till you kind of come up with, you know, something that you feel like looks good. But like I said, we removed the finish on this, so and it's kind of rough from our work with the files here. A little bit of a edge there. Let's check our bit here and see if our bit fits down in there. So depending on how much you have to remove, your bit that you had before might not be the right bit for it again. It might be a different bit, but this one still seems to fit pretty good. It still fits down in there. It's not wobbly, so I think we're all right with still using this. But we've got some more stuff that we need to do to kind of clean up this, so we'll go ahead and move on to that stage. We're gonna run this through a series of sandpapers. This is a 320, this is a 400. It's not that damaged. If it was, I would maybe go all the way down to like 220. I don't think I would go much lower than that, especially with the size that this is. So we're gonna go ahead and clean it up first. We're gonna chuck it up into a drill here, but before we do that, I'm just gonna take a tiny little piece of this paper towel here, kind of wrap it up around that. The reason why is your drill chuck has steel teeth in it, and when you go to chuck this up, it's probably gonna damage those threads, which is a whole nother problem. So now with that in there, at least there's a layer of soft between the screw head and our stuff. So we're gonna start with the 320. Use a little paint stick here. What I'm not trying to do is change the profile of this screw. For this particular pseudo action, we have 2 other screws, and what I don't want is 2 with square heads and 1 with a round head. So we're trying to repair it, not change it. Okay, nice and even. Still have some kind of deep gouges there on the front from the file, so we're gonna go ahead and, oh yeah. Okay, so now that's all smoothed out. We're gonna go ahead and switch over to some 400. And what we're left with here is screw. I hope that's in frame. It's completely repaired, smooth, clean, but not blue anymore. We have a couple of options on how to fix this. Looks like we gummed up the threads just a hair, but not too bad. Just in one little spot. So we have a couple options to re-blue this. We can use a bluing fluid, like Birchwood's Permablue. So we have this bluing fluid here. We could use, depending on if it was an aluminum fastener, which you're gonna find is more rare, you could use Aluma Black. For a single fastener, we could heat this one and turn it black. Let's do a couple. Okay, so we're gonna start out with heat bluing this. So the next thing, we'll be out in the shop again, and what we're going to do is heat this to critical and then quench it in an oil. And then what that'll do is turn it back to black or blue. All right, we're set up for doing our heat bluing. We're going to be using just some regular canola oil and MAP gas. Normally I would recommend using like used motor oil. I think it makes up for a blacker, but we're gonna go ahead and kick this on. We're going to put our it's glowing like that, we're going to punch it into the oil. Okay. And hopefully you can see there that it is all black. Back to Black. Great album. This is turning into one of the messier of the projects. So here is our heat treated, or not heat treated, heat blued screw, which being able to tell it apart from the others, very difficult. So I would call that a success. I'm going to blue it a second method, which for that I'm going to go ahead and take this bluing back off. So I'm going to chuck it back up into drill press, or drill rather. We're going to go back just to 400. I don't need to get rid of anything now. So we're just going to shine this back up. We are ready to re-blue this with chemical method using this Permablue. Now for this, we need to strip off the oils that are on from our hands and from quenching that and everything else. So for that, I'm going to grab some acetone real quick and I'll be right back. We're back to working with chemicals again too, so we're going to go ahead and put on our gloves. Open up this acetone, pour just a little bit into this little container here. Don't need a lot. And we're going to grab our little silver-headed screw. We're going to put it in there, do a little scrub with this ginormous cotton swab here. Very fancy. And grab a separate ginormous cotton swab here, even though it's way too big for this particular task. And we're going to grab just a little bit of this fluid. And we'll see if you can see this reaction. It's pretty quick. And look at that. Just a little bit more. Alright, that's a nice color, huh? The Bob Ross of fixing fasteners here. So we got it nice and dark again. I'm going to go ahead and go rinse it with cold water and I'll be right back. Alright, we're back with all 3 screws. This one's still a little bit wet from the water, otherwise I would have said try to guess which one it is, but you can tell with the 3 of them next to each other, they all have the same color. So that's 2 alternate bluing methods that resulted in very similar results. So I would call that a success for the first part of this, which was the fastener repair. Okay, for the next part of this, we're going to attempt to fix cross-threaded threads, which happens when the threads don't directly align and screw in like they're supposed to. So what we're going to do in order to do that is we're going to take one of our fasteners, one of our screws, and we're going to enter the center hole at a pretty extreme angle in order to create those cross threads. So that gives you kind of a pretty extreme view of how cross threaded I've got it down in there. So what we're going to do, just give it a little bit more tight. So now that that's cross-threaded in there and it's so tight I can't get it out with my fingers, we're going to use the proper screwdriver. We're going to back it back out of there. And you can see it's real goobered up there at the beginning. It's a technical term, goobered up. We're going to take our tap here, the same one. Now, if it's real extreme, you actually have to drill out the hole and go to the next size up tap and re-tap with a bigger thread and get a different fastener. But we didn't go in very far. We only went in a couple of turns, so we're just gonna go ahead and we'll bring that back out. And we will check and make sure that we can thread that in straight by hand. There you go. So we have repaired the cross threading that was in there from putting it in at an angle. All right, take that back out and we'll do the next step. What we're going to do is we are going to insert a screw into this last set here, this last hole rather. Put on our safety glasses and we're going to use our cutoff wheel here to remove this head of this screw here. We're going to use a different tool because this is taking forever. Let me go grab a different rotary tool. Let's go ahead and do this. Now you can see, you can just barely see the screw head now. It's flush. There's nothing sticking up. The way we were going to remove this is utilizing this and this. We're going to go out to the shop. We're going to use our center drill and our punch. We're going to punch a dimple right there in the middle of that, which we can do right now. Okay, we're back out in the shop. We are going to, we've already got this punched. We've got the center drill put in. We are ready to go. We're checked up in the vise. Now we can swap out this for the smaller bit. This is a very small bit that would be very easy to break, so we're going to be very careful. And put a little cutting oil right there. Now you can see got a hole inside of our little bit there. So let's go back inside and extract it. All right, we're back inside. We're chucked back up. And we're getting out the extractor here. That is stuck in the soft jaws of the vise. We're going to take this fluted extractor ever so carefully from the hole. Now remember, if it doesn't come right away, oil and heat are your friends. Be there. I wish they were always that easy, but they're not. You can see just a good one in there. Stuck on there good too. I'll get that off later. All right. That completes the week 8 FTT 111 final project, the Fasteners Repair Lab. Thank you very much for watching, and thanks for the opportunity over the last 8 weeks to learn from this course. Hope to have future courses, and hope you enjoyed the video. Thank you very much. Bye.